This is my pre-algebra course. Today we're going to learn how to evaluate algebraic expressions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We have to figure out what this expression equals when x becomes 4. So we're going to rewrite the expression, except instead of x, we're going to write 4. Now notice that I wrote parentheses here. We learned in previous classes that we show multiplication with parentheses in algebra courses. And so this is an algebra course, so we need to write our parentheses. We could use a dot, but we would prefer to use parentheses. And we certainly do not use crosses because we already have a cross for our variable. And why are we using multiplication? Well, we learned again in previous classes that when you have a number next to a letter, it means that the number is multiplied by the letter. So that's why we have to show multiplication here. Now, in the previous course, we'd show this expression with a cross. So that's what our expression would look like. But again, we can't use crosses anymore because crosses are used for variables. So we write this expression with parentheses. So now all we have to do is follow the order of operations agreement, and we use the acronym PEMDAS to remind us about the order of operations agreement. And if you haven't learned PEMDAS, that just means you do parentheses first, everything inside parentheses first, then you do exponents. We don't have parentheses or exponents in this expression. We do have parentheses, but everything in the parentheses is simplified already. So then we do multiplication. So multiplication is next. So 2 times 4 is 8, and 8 minus 3 is 5. So there's a lot of problems with order of where we have to use the order of operations agreement in this class. All right, let's try number 2. So again, we're just going to figure out what this expression equals when y becomes 2. That's what it means to evaluate an algebraic expression. We're evaluating this expression when y equals 2. So rewrite the expression and plug in 2 for y. Again, this is 6 times y. So we need parentheses for multiplication. 6 times 2 is 12. And 5 minus 12 is negative 7. All right, so let's try another one of these. Negative 3 times 10 plus 1. Again, we're plugging in 10 for z. Negative 3 times 10 is negative 30, and negative 30 plus 1 is negative 29. So why don't you try one of these problems? Go ahead and try number 4, and when you come back, we'll do it together. All right, we're back. We're going to plug in 1 for x, and order of operations tells us to multiply first, so 9 times 1 is 9, and negative 3 plus 9 is 6. So if you got 6, good job. All right, try number 5, and when you come back, we'll do it together. All right, we're back. So we're using parentheses for the multiplication. 5 times 2 is 10, and 10 plus 7 is 17. So if you got 17, good job. All right, now try number 6, and when you come back, we'll do it together. All right, we're back. So if you got negative 10, good job. All right, try number 7, and when you come back, we'll do it together. All right, we're back. Again, we're showing multiplication with parentheses. And we know to multiply because the number is next to the letter. And this is a condensed form here. Let's put that negative a little bit lower. That's condensed form. We learned in previous classes that the condensed form just means -8 plus -3, which is -11. Now, if you're having trouble with that, just go back to the previous classes and review that. Again, this is condensed notation. Don't overthink it. It's just telling us to add -8 and -3 to get -11. All right, so if you got -11, good job. All right, so let's do number 8 together. So notice we have no coefficient in front of the y. But there is a coefficient. It's just assumed to be -1. Because when you have a negative in front of a letter, you don't really need to put the 1. So mathematicians just condense that, and they just write the negative, and they leave the 1 off, but it's still -1 times y. We're still multiplying because the number's right next to the letter, so it's -1 times y. So now we just plug in 2 for y, because that's what y equals. So again, we're showing this multiplication with parentheses, and -1 times 2 is -2, and -2 plus 6 is 4. And I can go to the right there because I don't have any more room, so that's perfectly legal. All right, let's try number 9. Again, I want to rewrite that as -1 times z, and then I'm ready to plug in 11. 1 times 11 is 11, and 3 minus 11 is -8. All right, so why don't you try number 10, and when you come back, we'll do it together. All right, we're back. So I'm going to rewrite that as -1 times x. So if you got 2, good job. All right, try number 11, and when you come back, we'll do it together. All right, we're back. So if you got -5, good job. All right, try number 12, and when you come back, we'll do it together. All right, we're back. You don't really have to use every single one of these steps when you go into upper math. But we're just showing every detail here because we don't want to jump forward too much here. So if you got -2 for 12, good job. Try number 13, and when you come back, we'll do it together. All right, we're back. I'm going to have to condense this a little bit because we're running out of room. If you got -12, good job. Try number 14, and when you come back, we'll do it together. All right, we're back. So if you got -8, good job. Try number 15, and when you come back, we'll do it together. All right, we're back. If you got -2, that's very good. And try number 16, and when you come back, we'll do it together. All right, we're back. So if you got negative 18, good job. All right, on to number 17. So these problems are different because we're now starting to plug in negative numbers. So let's rewrite. But it's really just the same situation. We're multiplying. 4 times negative 3 is negative 12. And negative 12 plus 2 is negative 10. So there really wasn't a huge difference there. We're just plugging in a negative number instead of a positive number. All right, number 18. Plug in negative 2. And we have negative 4 times negative 2 is 8. And 8 minus 5 is 3. All right, so why don't you try number 19, and when you come back, we'll do it together. All right, we're back. We're plugging in that negative 1. Negative 5 times negative 1 is 5. 5 plus 7 is 12. So if you got 12, good job. All right, try number 20, and when you come back, we'll do it together. All right, we're back. So 2 times negative 2 is negative 4. Now I could write this form of the addition, but mathematicians don't, and that would be a lot easier to understand. But mathematicians don't do that. They write a condensed form of the notation, like so, and students really don't like that because it doesn't seem logical. But again, don't overthink it. It's just notation. So if you got negative 5, good job. All right, on to 21. Go ahead and try 21, and when you come back, we'll do it together. All right, we're back. Negative 6 times negative 6 is positive 36. And 36 minus 3 is 33. So if you got 33, good job. All right, on to 22. Go ahead and try 22. When you come back, we'll do it together. All right, we're back. Again, we're using parentheses for multiplication. And we know it's multiplication because we have a number next to a letter. So if you got negative 18, good job. All right, so now we're going to be faced with double negatives. So let's do this problem together. There's multiple ways to think of this. There's the fast way and there's the double negative slow way. So over time, when you become more fluent with algebra, you're going to use probably the fast way. The fast way is just to simply say this is a negative 2 and this is a negative 4. So they're going to become positive and it's going to become 3 plus 8. That's the fast way to do this. But a method that is probably easier to understand is to consider this 2 to be a positive and you're multiplying by negative 4. So positive 2 times negative 4 is negative. So positive 2 times negative 4 is negative 8. And then we consider this to be a double negative. Let me rewrite those negatives so they're a little neater. So we consider it to be a double negative at that point. And we learned in previous classes that a double negative, when negatives are right next to each other, they become positive. So that becomes 3 plus 8. All right, on to 24. Negative 2 minus 9 times negative 2. So again, The fast way is just to simply say negative 9 times negative 2 is positive 8. Or excuse me, positive 18. And our answer is 16. But the slow way is to say positive 9 times negative 2 is negative 18. Then we have a double negative. The double negative becomes positive. Negative 2 plus 18 is 16. All right. So why don't you try number 25, and when you come back, we'll do it together. All right, we're back. Again, the difference with these problems is we're plugging in negatives, and the negatives are changing the sign. So now we have 1 plus 40. I'm just going to do it the fast way, because you're going to have to learn it the fast way eventually. And so we get 41. If you got 41, good job. All right, number 26, attempt that problem, and when you come back, we'll do it together. All right, we're back. So if you got negative 1, good job. All right, let's do 27 together. So notice we have a negative sign in front of the x, but we have no number. We just have the negative sign. Again, that's assumed to be negative 1 times x. So now when we plug in negative 3, we have negative 3 times negative 1, which becomes positive 3. And 3 plus 1 is 4. So again, you got to be careful when you have a negative in front of a letter, because again, that means you're multiplying negative 1 times a letter, even though the 1 is not written. That's just condensed notation. So why don't you try number 28, and when you come back, we'll do it together. All right, we're back. So again, that becomes negative 1 times z. And z is negative 1. So negative 1 times negative 1 is positive 1. And then 1 minus 4 is negative 3. So if you got negative 3, good job. Another way to write this is to get rid of the 1. And you could just write it in this form, and we're going to do a couple problems that show that logic there. Again, mathematicians like to condense the notation, so you can get rid of the 1 in that case, and then it would again become positive 1. But we're doing it the long way, the less condensed way, so we don't confuse. All right, so let's try 29 together. 7. And then we have the 1 is the coefficient there. So we have negative 1 times negative 2, which is positive 2. And 7 plus 2 is 9. So if you got 9, actually, well, you didn't try that one on your own. So why don't you try number 30, and when you come back, we'll do it together. All right, we're back. So we're just writing that coefficient there. Plug in the negative 8. And negative 3 plus 8 is 5. So if you got 5, good job. Again, you can write this as a double negative, but that just takes time, and eventually you're going to need to use the faster method anyway. So try number 31, and when you come back, we'll do it together. All right, we're back. So that's negative 1 times z. So if you got 8, good job. All right, try number 32, and when you come back, we'll do it together. All right, we're back. So again, I'm going to rewrite it because the coefficient is in condensed form, or it's not there. So I wrote the 1, the coefficient, and now we have 11 plus 8 is 19. So if you got 19, good job. All right, try number 33, and when you come back, we'll do it together. All right, we're back. So if you got -3, good job. Try number 34, and when you come back, we'll do it together. All right, we're back. So if you got -8, good job. All right, so now we're going to division. In the previous problems, we did multiplication, and we showed that multiplication with parentheses. So, so far, the difference between what we're doing now and what we did in my previous course, or whatever arithmetic instruction you had, was that, number one, we didn't use negatives, obviously. Now we're using negatives. And the second thing is we're using parentheses for multiplication, whereas we use crosses for multiplication. So now we're going to division. In previous courses, we would show this this set of operations as z divided by 2 plus 1. But in this in algebra, you really don't show division with this sign anymore. Sometimes you do, but not very often. Instead, you use a fraction sign to mean to notate division. So we're just going to get some practice using fraction signs for division. So let's go ahead and plug in our z value, and we're going to evaluate the expression. So z is 18. You know what, I'm going to get in the habit of drawing that in the middle of the line there. So 18 divided by 2. Remember, PEMDAS tells us we have to divide first, then add. And in case you forgot that PEMDAS, I'm going to write it here. Again, that's just an acronym that tells us which operations to perform first. It's a way. It just tells us how to communicate with other mathematicians. So we do division first, then addition. So 18 divided by 2 is 9. And 9 plus 1 is 10. So let's try another one of those together. X is -1. So now we have 5 plus -1/3. And remember, you can't put a positive and a negative next to each other without parentheses. That's just the way it is. And the parentheses doesn't really mean multiplication, although you could write multiplication because that's the same thing as +1 times -1/3, which is just -1/3. I know it gets kind of complicated there. But mathematicians, they don't want to write these parentheses and these positive signs, so they just write 5 minus 1/3. So now we could divide these and get a decimal, but it's easier to just keep it as a fraction. So now we're going to get a common denominator. So this any whole number can be written as over 1. So we now have two fractions. If I move that up, we're going to multiply both sides of this fraction by 3 to get 15 over 3. And now we have 15/3 minus 1/3. And 15/3 minus 1/3 is 14/3. So in that case, we weren't really dividing, we were just making it a fraction. So sometimes you can divide, but other times you just consider it to be a fraction. It just depends on if it's an improper fraction or or a proper fraction, or if it's if the number on the numerator is divisible by the number in the denominator. All right, so why don't you try number 37, and when you come back, we'll do it together. All right, we're back. So we're going to plug in that negative 12 for y. And negative 12 divided by 4 is negative 3. And negative 3 minus 3 is negative 6. So that's an example of that condensed notation that we learned previously. All right, so why don't you try number 38? For 38, you're just going to get a proper fraction, so we're not going to really divide. We're just going to have to add a negative fraction and a positive whole number. So remember to write 2 over 1 and then get a common denominator. So attempt number 38, and when you come back, we'll do it together. All right, we're back. So we're going to just plug in that 5 for z. And now we have to get a common denominator, and we have to treat the 2 as a fraction, as I mentioned before. So any whole number can be written as over 1. In fact, any value pretty much at all can be written as over 1. Even a fraction can be written as over 1. But we're turning the 2 into a fraction. So now we're going to multiply both sides of this fraction by 5. And that will give us 10 over 5. And now we have a common denominator. So negative 3/5 plus 10/5 is 7/5. All right. Why don't you try number 39, and when you come back, we'll do it together. All right, we're back. So it's probably best to write parentheses there. And negative 25 divided by 5 is negative 5. So then you can either write it like this, or you can write it in the condensed notation, which is really preferable, because that's what you're going to see in upper math. You're not really going to see this in upper math much. You will see it sometimes, but you'll mostly see 8 minus 5. So if you got 3 for 39, good job. So why don't you try number 40? That's going to be somewhat of a challenging problem. And when you come back, we'll do it together. All right, we're back. So now we have to get a common denominator, so I'm going to raise that one up a little bit and change it into a fraction. Any whole number can be written as over 1. Multiply both sides of this fraction by 8, and we get negative 8 over 8. And negative 8 minus 7 is negative 15. That's just condensed notation. So if you got negative 15 over 8, good job. All right, on to number 41. Go ahead and try number 41, and when you come back, we'll do it together. All right, we're back. So I'm going to plug in that value. Negative 56 divided by 7 is negative 8. And negative 8 plus 4 is negative 4. So if you got negative 4, good job. Now, let's do 42 together. With 42, we're going to get a fraction where we can't really change it. We can't really turn it into a whole number or a decimal. We could change it to a decimal, but that would make things a lot more difficult. Much more difficult. So how do we deal with this? Well, remember we talked about how if you have a negative in front of a fraction, you can take this negative and you can put it next to the fraction line, which means the whole fraction is negative, or you can put it in the numerator, or you can keep it in the denominator. But wherever you keep it, just know that this entire fraction is considered to be negative. So now we have to get a common denominator, but first we have to change the 2 so it looks like a fraction so we can understand it. as combining fractions. So multiply both sides of this fraction by 11. And you get 22 over 11. Negative 6 minus 22 is negative 28. So we have negative 28 over 11. And yes, negative 28 over 11 is an improper fraction, but remember in algebra, we typically just leave improper fractions. All right, so for number 43, something different is going to happen here, because now we're plugging in a negative to these fraction expressions. And so, as you might expect, because we have two negatives next to each other, those two negatives are now going to become, they're going to change to a positive. So we're left with positive 2/3 plus 2. And again, we just combine those. We could just write it as 2 and 2/3 if we wanted to use a mixed number, but in algebra, mixed numbers just aren't used very much. So 6/3 plus 2/3, well, I gotta go ahead and show that. So multiply both sides of this fraction by 3, and you get 6/3. And 6/3 plus 2/3 is 8/3. So in these problems, we're just doing double negatives, so just be aware of that. So try number 44. When you come back, we'll do it together. All right, we're back. And notice how I'm writing parentheses here. If we didn't write parentheses, it would look kind of strange, because again, you're not allowed to put two negatives together without some sort of parentheses there. So now we have negative 4 divided by 2, which is negative 2, and now we have a double negative. So double negatives become positive, and you have 5 plus 2, and 5 plus 2 is 7. So if you got 7, good job. All right, so why don't you try 45. Remember, when you plug in that negative, it's best to write parentheses. And when you come back, we'll do it together. All right, we're back. And the double negatives become a positive. And that 6 we can write as over 1. Multiply both sides of this fraction by 2. And you get 12 over 2. And 3 halves plus 12 halves is 15 halves. So if you got 15 halves, good job. So try number 46, and when you come back, we'll do it together. All right, we're back. So again, it's best to write parentheses here. So now we have a double negative. The double negative becomes positive. So we have negative 3 plus 5, 6. And I'm going to write that negative 3 is over 1, so now it becomes a fraction. Multiply both sides of this fraction by 6, and you get negative 18 over 6. And negative 18 plus 5 is negative 13. So negative 13 over 6. So if you got negative 13 over 6, good job. All right, on to 47. Go ahead and try number 47. When you're done, we'll do it together. All right, we're back. Negative 2 divided by 2 is negative 2, or excuse me, negative 1. And I'm using the condensed notation here. So now we have a double negative. So the double negative becomes a positive, and 1 plus 1 is 2. So you can see we had a double negative, which became a positive. All right, so on to the next problem. Try number 48. When you come back, we'll do it together. All right, we're back. So that double negative becomes a positive, and that 4 becomes 8 over 2. 8 over 2 plus 7 over 2 is 15 over 2. So we got 15 over 2. Good job. All right, on to number 49. So now we have more complicated fraction problems. Notice we have an operation in the numerator. So when you see this, you want to perform the operation in the numerator first. Then you can consider the entire fraction as a whole. So, so it looks like we're going to violate the order of operations agreement, because we're going to perform addition before we perform division. We're going to perform addition before division. But we're not really violating the order of operations agreement, because if we were to write this out, it would be x plus 2 in parentheses divided by 3, if we were to use the old notation, minus 1. So we're not really violating the order of operations. We're just assuming that because this is the numerator, everything in the numerator has to be divided by the denominator, which means we have to perform the operations in the numerator first. So again, it looks like we're violating the order of operations, but we're really not. So let's plug in our 1 for x. And so again, we're going to add first, even though it looks like we're violating the order of operations, and we get 3 over 3 minus 1. And 3 over 3 is 1, and 1 minus 1 is 0. All right, so why don't you try actually let's do number 50 together. Well, actually you can try number 50. Go ahead and try number 50, and when you come back, we'll do it together. All right, we're back. Seven minus 10 is negative 3. But again, we can't just write a negative and a positive sign together. We have to put parentheses. But again, most mathematicians would just skip that step and write the condensed form of the notation, which you see here. So again, same situation. We just write over 1, and that becomes 8 halves. 8 halves minus 3 halves is 5 halves. I don't think I need to keep showing that math over and over again, hopefully. All right, so number 51, same situation pretty much. Go ahead and try 51, and when you come back, we'll do it together. All right, we're back. So we have multiplication, so we have to show parentheses. And now, again, we have to do everything in the numerator first. So we have to use PEMDAS, so we have to do the multiplication first before we do the subtraction. So negative 2 times negative 1 is positive 2. And 2 minus 5 is negative 3. And now we can divide, but we don't really need to divide, because why would we? We just leave it as negative 3/7. Now if we had negative 21 over 7, then we can definitely divide and get negative 3. But since the numerator is smaller than the denominator, we already have a proper fraction, so we can just leave it there. Try number 52, and when you come back, we'll do it together. All right, we're back. So we're just evaluating the expression by plugging in -3. And we get -6 minus 1 over 5. Which is -7 over 5. So if you got -7 over 5, good job. Now 53 is a little different because the variable is in the denominator, but that's okay. It's really the same type of problem. So go ahead and try 53, and when you come back, we'll do it together. All right, we're back. So 3 over -2 minus 1. So we cannot divide 3 by the denominator unless we first simplify the denominator. So that becomes 3 over -3. And then 3 divided by -3 is -1. So if you got -1, good job. All right, 54 is a little different there. Why don't you try 54? And when you come back, we'll do it together. All right, we're back. So a lot of things going on here. So we need to simplify the numerator and simplify the denominator. So 3 times 2 is 6. 4 times 2 is 8. 6 minus 1 is 5. 2 minus 6 is, or 2 minus 8 is -6. So -5/6 is our answer. Again, you can put that negative in the denominator, or you can put it in the numerator, or you can put it next to the fraction sign. It's not really it's not standard to put it in the denominator, but I don't want to have to rewrite it, so I'm just going to leave it there. It's not really wrong. It's just not it's not usual to do that. All right, so if you got -5/6, good job. All right, so now we're going to go back to multiplication. You can see that we have a number next to parentheses, which means we're multiplying 5 into all these parentheses. So let's go ahead and plug in the number. So x is 1. Now, let me just show you what this would look like in the previous course when you're taking arithmetic. It would look like 5 with a cross, meaning multiplication. And this is what you saw in my previous course, or this is what you saw when you took some sort of arithmetic course. You didn't see the 5 right next to the parentheses. You saw a cross, but again, we can't use a cross because we're using the cross for a variable, or as a variable. So again, in algebra, you get rid of the cross and you just write the number right next to the parentheses, and that means that you're multiplying 5 into whatever is inside the parentheses. So that's what it means when we write 5 right next to the parentheses. But also remember, PEMDAS tells us that we have to simplify the parentheses first, so don't multiply that 5. Do not multiply it yet. We have to simplify the parentheses. So 1 plus 2 is 3. So now we've simplified what's inside the parentheses. But don't multiply that 5 yet. Don't do it yet. PEMDAS tells us do the exponents next. And I'm going to write PEMDAS over here in case. Now, if you're my student from my previous class, you don't really need me to keep showing that. But if you're coming from a different class, you may need to have a reminder there. I mean, a different course. And so we need to do exponents first. We did parentheses. That was this part. And now we need to do exponents. So 3 to the second power, that means 3 times 3. So that would be 9. Now notice that I didn't get rid of my parentheses. I still need my parentheses because the 5 is multiplied by whatever we get after we perform the power operation. So I have to keep those parentheses. Now we do multiplication. So we're moving on to the m part of PEMDAS. So 5 times 9 is 45, and 45 plus 3 is 48. All right, so let's try one more of these together before you try one on your own. So I'm just going to plug in that number. So now again, it just becomes PEMDAS. The only difference is that I don't have a cross here to show the multiplication. I'm just putting the number right next to the parentheses. So again, it's crucial that you understand that when this number is right next to these parentheses, it's multiplying the number into the parentheses. It's very, very different from what we learned in the previous class. So PEMDAS tells us to do the parentheses first, and I'll try to keep PEMDAS in the window there. So 2 minus 4 is negative 2, and I got to keep those parentheses. A lot of students will get rid of the parentheses, but then if you do that, it'll look like you're subtracting the 2 squared, and things will get very, very weird, and you're going to come up with the wrong answer. So then PEMDAS tells us to do the exponents next. So negative 2 to the second power is positive 4, because that's negative 2 times negative 2 is 4. Now just be aware that this 2 here has nothing to do with that power. The 2 raises what's in the parentheses, and that's it. It raises this part, that's it. This 2 has nothing to do with the power. So now we have 2 times 4 is 8, and 6 minus 8 is negative 2. Let me just double check that. Looks right. All right, so now it's time for you to try. Go ahead and attempt 57, and when you come back, we'll do it together. All right, we're back. Now we have a double negative. So I'm sorry to give you a double negative problem on your own there, but you know double negatives, so you should get this. So we do the parentheses first, so we have a double negative, so that becomes 1 plus 1. And so now 1 plus 1 is 2. And notice that I wrote those parentheses there. I have to keep those parentheses. And we're going to discuss later on. If I left those parentheses off, if I didn't write the parentheses and I just wrote this 2 next to the other 2, then do you see what would happen? This looks like 22 to the second power. So we can't do that. We got to have parentheses on that 2. This is where things start to get kind of weird here. So the 2 is raised to the second power, and then you multiply it by the 2. Again, this is why algebra is considered to be so difficult. It's a language that you have to become fluent in, and it's not exactly easy to learn all these little details. But if you don't learn the details, you don't know the language, then you're going to get the wrong answer. And that's a big problem if you're an engineer or a scientist. So now we do the exponent 2 to the second power is 4. And keep those parentheses, and 4 times 2 is 8. 1 plus 8 is 9. So if you got 9, good job. All right, let's try one more of those. So try number 58, and when you come back, we'll do it together. All right, we're back. So we plugged in our number there. And PEMDAS tells us to do the parentheses first. Negative 4 plus 3 is negative 1. And negative 1 squared is positive 1. And negative 3 times 1 is negative 3. And negative 3 minus 8 is negative 11. So if you got negative 11, good job. All right, so here's where things start to get pretty involved as far as the notation. This is where students start to have some big problems when it comes to making mistakes because of the complexity of the notation. It's not really that complex. It's just something that students tend to make mistakes on. So in this problem, this problem is going to be very easy, but I'm going to use this problem to compare problems that are going to be much more difficult as far as the notation goes. So let's plug in the 3, and we have 3 squared plus 1. PEMDAS tells us to do the exponent first, and then 9 plus 1 is 10. So that was not difficult. That was pretty easy. But the important thing I want to point out is notice that I did not put parentheses on that. I didn't put parentheses around that 3. I didn't need to. But this was just a very special case where you didn't need to write parentheses around the 3 that you plugged in the power operation. In almost every single case, you're going to have to write parentheses, because if you don't, the expression is going to be misinterpreted. This is just one special case where you don't have to. So now let's go to the cases where you do have to write parentheses, and if you don't write parentheses, you're going to have a big problem. So number 60 is a perfect example of that. The difference between number 60 and number 59 is that with number 60 we have a coefficient. Whenever you have a number next to a letter, that's called a coefficient. But over here we didn't have a coefficient. Now technically the coefficient is considered to be 1, but we don't write it, so there's no coefficient written. So let me tell you why in this problem we do have to write parentheses. So if you plug in the 3, you must write parentheses, where in this case we plugged in the 3 to the power expression and we didn't need parentheses. So why is that? Well, here's the reason. Look what happens if you don't write parentheses over here. I'm going to take away the parentheses, and now look what you have. Okay, it doesn't take a genius to figure out that there's something that's going to be misinterpreted here. That looks like 43 to the second power. That's not what we're doing. We're doing 4 times a square. Remember, square is another way to say to the second power. So we're multiplying the 4 times the square. We're not raising 43 to the second power. Okay, but over here we didn't have that problem, because when you have a coefficient of 1, you don't write the 1. Now look what would happen if I did write the 1. And again, I don't want to bore you by going over this too much, but this is just the type of thing that students really get confused. So if I wrote the 1, and again, I can do that. That's not wrong, but it's just traditional to leave the 1 off. But if I had that 1 there, and I just plugged in the 3 without parentheses, then I would have 13 to the second power. I would have the same problem. But this is just the rare case where you don't have to write parentheses, simply because the 1 is not written. It's traditional to leave the 1 off. We don't need the 1. So in this case, you don't have to write parentheses because there's no 1 here that makes it look like 13. But over here, there's the 4. So if you don't write those parentheses, it looks like 43 to the second power. So as you learn this stuff, as you do the homework, and I stress, as you do the homework, you're going to start to learn fluency. You're going to start to understand how this stuff works, the logic of it. Sometimes math notation doesn't have logic, but in this case, there's some logic here. You got to show those parentheses, or else it's going to look like something different. So now we raise 3 to the second power, and we get 9, and we got to keep those parentheses because we're still multiplying. And 4 times 9 is 36, and we rectangle the 36. Okay, so number 61 and number 62 show this the difference between these situations. So now I want you to try 61 and 62. Now remember, in 61 you don't have to write parentheses because there's no coefficient written, because the coefficient is considered to be 1. But here you do have to write parentheses because it's going to look like negative 51 to the second power if you don't. So try 61 and 62, and when you come back, we'll do it together. All right, we're back. So 3 plus 1 squared. 1 squared is 1, and 3 plus 1 is 4. So if you got 4, good job. But the key thing to understand is you don't need parentheses when you plug in that 1. But for number 62, you do need parentheses. Because if you didn't write parentheses, if I wrote it like this without the parentheses, then it would look like negative 51 to the second power. And that's not a good thing. So 1 squared is 1, and I got to keep the parentheses still. If I wrote the second step without parentheses, it would look like 51. It would look like that would be my answer. But you got to keep those parentheses, and negative 5 times 1 is negative 5. It's so easy for students to think that the answer is negative 51. But again, you have to follow order of operations. You have to know this language. It's not easy to learn this language. It takes some practice, and I stress practice. You must do the homework. When you do the homework, you're going to find that you're going to make a lot of mistakes, and that's where you start to learn. That's where the learning process begins. But a lot of students, they like to complain and say, well, I don't understand it. Well, saying you don't understand it is usually just a way to be lazy and say that you don't want to do the work. You have to learn this language, so don't be lazy. Don't give excuses. You're going to make mistakes, and you're going to fix those mistakes, and you're going to do the homework completely and correctly. All right, so now you can see we have a red star there, so that means something different is going to happen. And the difference here is now we have a negative number that we're plugging into a power expression. So there's another situation here where there's a huge potential to make mistakes as far as the notation goes. When we plug in this negative 6, there's two ways to do it. We can plug in without parentheses, or we could plug in with parentheses. Now, which one do you think is going to be correct? One of those is correct. One of those is not. Is it this one, or is it this one? Well, if you said parentheses, you're correct. This is the correct method, or the correct notation. This is incorrect. And again, this is a special case. This is a special situation where because we have a coefficient here, but the coefficient is not written, there's potential for confusion. So let's go through the different scenarios here. So let's say that we plug in the 6 without parentheses. So again, the negative is assumed to be negative 1 times 6 squared. That's what this actually means. It means negative 1 times 6 to the second power. And this means something very different. This means negative 6 times negative 6. So the difference is that here you get a negative times a negative is a positive. Here you get 6 squared is 36, and then 36 times negative 1 is negative 36. So with this notation, you get a positive 36, and with this notation, you get a negative 36. So it's a very small difference between these expressions, but one gives you a positive and the other gives you a negative, which is not a small difference. That's a huge difference. If you're an engineer or a scientist, you're going to have big problems if you misinterpret that. So typically what students do is they will write this form, and the reason they're going to write that form is because they're going to want to write the expression with the least amount of work. They just they don't want to write parentheses. Why would you need to write parentheses? You can just consider that to be positive 36. Now this is a situation where when I tell students the correct way to do it, oftentimes they just ignore me. They just say, well, you're just splitting hairs. You know, I can write it like this. I don't need to write the parentheses. Well, when you see this expression in math, it means negative 36. So when you write this, somebody else is going to misinterpret your work. And most likely, you are going to misinterpret your own work. because when you see this written down by other people, it's interpreted as -36. That's the correct way to interpret it. So there's a lot of potential for confusion when it comes to that. You must write parentheses around the -6. So that means that everything is squared, not just the 6. The negative is squared too, because the negative is part of the variable, and we're told that the variable is squared. So you must square the -6, all of it. So that becomes -6 times -6 is +36. So do not write this notation, because you're gonna run into a lot of problems in the future. And again, a lot of students will just ignore me. They'll say, you're splitting hairs there. We're not splitting hairs. The difference between +36 and -36 is not splitting hairs. That's the difference between whether or not a space shuttle or a plane crashes or comes down from the sky, if you're an engineer or a scientist. So don't tell me that we're splitting hairs. You must learn the proper notation. So try number 64, and when you come back, we'll do it together. All right, we're back. So again, you got to use parentheses when you plug in that -3. -3 times -3 is 9. If you wrote -3 without parentheses, you did it incorrectly. All right, so try number 65, and when you come back, we'll do it together. All right, we're back. -1 squared, you got to write it with parentheses, and it becomes +1. So if you got +1, good job. Try number 66, and when you come back, we'll do it together. All right, we're back. So -8 squared is +64. Again, if you wrote it as -8 squared without parentheses, that would be -64. That would be completely wrong. And again, I just want you to be aware, this is a special case where you don't have a coefficient here. I mean, the coefficient is assumed to be 1, but you don't write it. So that's where the confusion comes from. If you have a coefficient there, then the problem is not, the problem really goes away for the most part. But you still have to write parentheses. All right, so try 67, and when you come back, we'll do it together. All right, we're back. If you got 16, good job. All right, so now we're going to a slightly different problem. Now, in this problem, we can write the other type of notation. So let me demonstrate. That negative goes on the outside. It's not part of y, so it just goes on the outside. It doesn't go in with parentheses. Then we just write the 3 squared. So this type of notation, in this situation, writing the expression without parentheses, without these parentheses, is actually correct. Because again, the negative is outside. So we're raising y to the second power. We're not raising the -1 to the second power. So when you plug in y, you plug in 3 for y, 3 is raised to the second power. The negative is not raised to the second power. Now I can write parentheses here. That's okay. You know, that's not wrong, but I don't really need parentheses. So this is a special case where you don't have to write parentheses. Now, if we had an expression like -5y squared, then I would definitely have to write parentheses. Because if I didn't, it would look like -53 squared. But this is a special case where, because there is no number here, it's assumed to be -1, but the 1 is not there, we don't have to write parentheses. So these are little details that are so confusing to students. This is all part of the math language. When you learn English, there's all these rules that are difficult to memorize, and the only way to get to the point where you can use the language quickly is if you do a lot of practice. And when you speak the English language, you're constantly practicing over and over and over and over again, to the point where it doesn't matter how sophisticated or how difficult the language is, you're going to learn it eventually, because you have so much practice. Well, when it comes to mathematics, it's the same situation. There's a lot of really difficult things in this language, but if you do the homework and if you get a lot of practice, you're going to become fluent in the language. It doesn't matter how sophisticated it is. So now 3 squared is 9, and again, the negative is not part of the square, so it's not negative 3 times negative 3. It's just 3 times 3, and then the negative just hangs out in front. So another way to think of that is you have, again, negative 3 squared is the same thing as negative 1 times 3 squared. And negative 1 times 3 squared is just 3 times 3, which is 9, and then 9 times negative 1 is negative 9. That's another way to think of it if you want to write it all out. So again, you don't have to use parentheses. So try number 69. And again, I showed all those steps down here, but you don't really need to show the steps. All you need to do is remember that notation means that you're multiplying negative 1 into the square. You don't have to show every single step. So try 69, and when you come back, we'll do it together. All right, we're back. So we don't need parentheses. I almost wrote the parentheses there, but we don't really need them. And that equals negative 16, and that's your answer. So if you got negative 16, good job. If you got positive 16, then something is wrong. You're doing something wrong. So now try 70, and when you come back, we'll do it together. All right, we're back. So again, this is the special case where you don't need parentheses. So if you got negative 4, good job. Try 71, and when you come back, we'll do it together. All right, again, this is the special case where you don't need parentheses. So if you got negative 1, good job. So again, that's a huge source of error for students. I just want to make it very clear. Negative x squared, well, I should use an example number here. Let's try 3. Negative 3 squared is not the same thing as negative 3 squared with parentheses. This is negative 9, and this is positive 9, so they are not equal. That's one of the biggest sources of error for students. And you tell them, and they don't listen. They just ignore it. They think it's not that big of a deal, but then you go to do the homework, and you start to have problems. And then you really have to, you either do the homework incorrectly and just leave it to where it's incorrect, or you figure out the proper notation and do it correctly. It just depends on your dedication. So now we go to a third type of problem where we have a negative in front, but we're also plugging in a negative. And in that case, you would write it like so. But again, this negative has nothing to do with this power. So let's write the negative with the 1 added in there. So again, you have parentheses, which means that you're multiplying whatever this expression is by the negative 1. But PEMDAS tells us to do exponents first. So we have to do negative 9 times negative 9 is 81. And then negative 1 times 81 is negative 81. So that's what's going on there. So again, you have the special case where there's no number there. But even if you did have a number there, you would have to write the parentheses in this typical case, or this special case. So now negative y squared, plug in the y, and we have to raise negative 5 to the second power. We get 25, and then the negative 1 just stays in there, so I did a faster version of that. Negative 25. You can show these steps if you want, but you don't really have to. As long as you understand what it's telling you, you don't have to show every single step. So why don't you try 74, and when you come back, we'll do it together. All right, we're back. So we have to use parentheses in this case. And by the way, don't think that because these negatives are next to each other, they're going to become positive. No, you have to follow the order of operations. You have to square the negative 1 first. So you square the negative 1, it becomes positive 1, and you're left with negative 1. So if you got negative 1, good job. Try 75, and when you come back, we'll do it together. All right, we're back. Plug in that negative 2. Negative 2 to the second power is 4, and you're left with negative 4. Again, 4 times negative 1 is negative 4, but you don't have to show that, that step. All right, so 76 and 77 are designed to show you the condensed notation. So this expression, technically you can see negatives added on and on and on and on and on, just like we saw negatives here. But you can just keep adding more and more negatives with parentheses. So that means negative 1 times negative 1 times negative 2. That's what that actually means. So you do the parentheses part first. So negative 1 times negative 2 is positive 2. And negative 1 times positive 2 is negative 2. So that problem ended up being negative 2. So I'm not going to give you a lot of these problems. I'm just showing you the principle that technically those negatives just mean times negative 1. And I don't think I meant to write so many parentheses here. I'm going to take one of those off. There you go. All right, and then negative 3. So again, we're just multiplying negative 1 times negative 1 times negative 1 times negative 1. Or excuse me, times negative 3. So we're going to do the inside part first. So negative 1 times negative 3 is positive 3. And then we have negative 1 times positive 3 is negative 3. And the negative 1 times negative 3 is positive 3. So whenever you have an even number of negatives, you're going to get a positive. We have 4 negatives, which is even numbers, so you're going to get a positive. Here we had an odd number of negatives. We had 3 negatives, so it became a negative. But again, I'm just showing you that. I'm not going to give you a lot of those problems. I'm just showing you that to demonstrate that the condensed notation is used when you're multiplying negative 1. All right, so now we have a situation where the coefficient is not 1. In all the previous problems, we dealt with a special case where the coefficient was 1. But now we're dealing with a situation where the coefficient is not 1, so we're going to plug in negative 4. And we definitely need parentheses, because if you plug in negative 4 without the parentheses, it looks like 4 minus 4 squared. And the difference is that this would be 4 minus 16. So here you're multiplying the 4 into the square. You're multiplying, let me get my highlighters out. You're multiplying 4 times the square. But if you just put negative 4 without parentheses, it looks like you're subtracting the square from 4. And that is completely different. So these little nuances need to be understood. And that's what the purpose of this course is, to learn the language of algebra. So negative 4, we have to use PEMDAS, exponents first. So negative 4 squared is positive 16. And again, I'm just rewriting these 4s, and I want to make that clear. I'm going to use colors. This becomes this, and this becomes this. I'm going to write that a little better there. So then 4 times 16, that's kind of a big number. We can do that off to the side, or you can get your calculator. That would be 64. All right, so let's do this one together, and you can do the next one on your own. So again, we have to have parentheses, or else you're gonna get the wrong answer. It's going to look like something completely different. If you don't write the parentheses, then this expression is completely different from this expression. So you must write those parentheses to show that you're raising the negative 2 to the second power, and not just the 2 to the second power. And you're multiplying z squared times negative 5. You're not subtracting 2 squared from negative 5. There's just so many ways to misinterpret this. You have to know the language of algebra. So negative 2 squared is positive 4, and we have to keep the parentheses because we're still multiplying. Remember, when you put a number next to a letter, it means you're multiplying the number. So negative 5 times 4 is negative 20. So there you go. So now try number 80, and when you come back, we'll do it together. All right, we're back. So again, you must use those parentheses. Negative 1 squared is 1. 4 times 1 is 4. So if you got 4, good job. All right, try number 81, and when you come back, we'll do it together. All right, we're back. So you must use parentheses. If you didn't use parentheses, you did it wrong. Negative 3 squared, that becomes 9, and you must keep your parentheses. And then negative 3 times 9 is negative 27. So if you got negative 27, good job. Try number 82, and when you come back, we'll do it together. All right, we're back. So here's a situation where we're not plugging in a negative, but we still need the parentheses, because if you don't write parentheses, you have negative 23 squared, and that means you're squaring 23 and then multiplying it by a negative, and that's just ridiculous. That's not what this notation is telling us. So even though you're using a positive, you must use parentheses. So 3 squared is 9, and you got to keep your parentheses. Negative 2 times 9 is negative 18. So if you got negative 18, good job. All right, try number 83, and when you come back, we'll do it together. All right, we're back. So again, you must use parentheses. 2 to the second power is 4. Keep your parentheses. Negative 6 times 4 is negative 24. So if you got negative 24, good job. All right, so number 84, something different is going to happen, because now we have a cube, or what we call a cube, that we're raising to the third power. And so when you're raising to the third power, the signs are going to be a little different. But the notation for plugging it is exactly the same. So let's do this one together. So you plug in your negative 1, and you know what raising to the third power means. It's very easy. It's just negative 1 times negative 1 times negative 1. So negative 1 times negative 1 times negative 1. What would that be? You tell me. Negative 1 times negative 1 times negative 1. Well, obviously it's going to be 1, but what is the sign? Is it positive or is it negative? Well, negative 1 times negative 1 is positive, and then you multiply by the third negative 1, and it becomes negative. So that would be negative 1. Again, when you raise a negative to an odd power, it's always going to be negative. When you raise it to an even power, it's always going to be positive, except this was not a negative, so that didn't really apply. So negative 2 times negative 1 is positive 2. All right, so now you try one of those problems, and when you come back, we'll do it together. All right, we're back. So negative 2 to the third power, that's negative 2 times negative 2 times negative 2. So if you said that that was negative 8, you're correct, because negative 2 times negative 2 is positive 4, and then positive 4 times the third negative 2 is negative 8. Negative 4 times negative 8 is 32. So hopefully you're not having trouble with that. That's just the basic definition of raising to a power. You take whatever you're raising, and you multiply it 3 times. Why are you multiplying it 3 times? 1, 2, 3. because the power is 3. The power tells you to multiply it 3 times. So negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. That's where we got this negative 8. But you don't really have to show all that. You can just do it in your head. All right, on to number 86. Go ahead and try number 86, and when you come back, we'll do it together. All right, we're back. So again, you need parentheses. You have to have those parentheses. And I just realized it looks like this is the same type of problem. We have 2 times negative 8, and 2 times negative 8 is negative 16. So if you got negative 16, good job. But that was too easy, so let's change that to a 3, because that was pretty much the same problem we just did. Let's change that to a 3. So 2 and negative 3 to the third power, so see if you can do that one. And when you come back, we'll do it together. All right, we're back. So if you said negative 3 to the third power was negative 27, you were correct. Negative 27. And 2 times negative 27 is negative 54. All right, so that's our class today. A lot of nuances there. Again, we learned how to evaluate expressions in this class. And as you can see, because we have negative numbers in this course, and we have parentheses for multiplication and fractions for division, and we have the principle that a letter next to a number is multiplication, and so on and so forth, things start to get pretty involved when it comes to the notation. And this is where the source of error comes into play. There's a lot of potential to make mistakes with this stuff. This is all the work that we did today. If you'd like to take screenshots of these pages so you can use them for your notes and to help you with the homework, go ahead and take screenshots. You can use these screenshots to help you study for tests also. So now let's look at the homework. So get a screenshot of that, and get a screenshot of this. Do the homework completely and correctly, and check all your answers and show all your work. And whatever you do, make sure that you get that homework done. The homework is not optional. It's a requirement. Do it completely and correctly. And if you get the wrong answer, go back and figure out what you did wrong. And I'll look forward to seeing you in the next class.